For most of human history, scientists assumed the deep ocean was empty, too dark, too cold, too much pressure for anything complex to survive. That assumption held until the first cameras went down far enough to prove it wrong. In 1916, the bathyscaphe Trieste descended to 10,916 meters, the deepest point in the Mariana Trench, and pilot Downer Walsh reported seeing a flatfish moving across the sediment at the bottom. At that pressure, in complete darkness, alive. In 2014, a NOAA remotely operated vehicle descending into the trench filmed an unidentified gelatinous organism at 8143 meters, that biologists could not assign to any known species for over a year after the footage was reviewed. Those were just the things the cameras could identify. The last entry in this video is not a creature at all. It is a sound, recorded at depth by researchers at Woods Hole Oceanographic Institution, that matched the acoustic profile of something biological at a volume no known animal on Earth can produce. It has never been formally explained. Every expedition that has gone down has come back with something that rewrote the rules. This is what they found. The Mariana Trench runs approximately 2,550 kilometers through the western Pacific Ocean, east of the Mariana Islands at its deepest point. The Challenger Deep, it reaches 10,935 meters below sea level. Stack Mount Everest on top of itself, and you would still not reach the surface from the bottom. The water pressure down there exceeds 1,000 times the pressure at the ocean surface. A human being, unprotected, would be compressed to nothing in seconds. For most of the 20th century, that environment was considered, by scientific consensus, to be as hostile to complex life as the surface of another planet. No light, no warmth, almost no food. The assumption. It was also wrong in ways that have taken decades to fully appreciate. Systematic deep-sea exploration of the trench began in earnest after the Trieste descent in 1960, accelerating through the 1990s as remotely operated vehicle technology advanced far enough to survive those pressures and return usable footage. Each expedition revised the conclusions of the one before it. Not incrementally, fundamentally less than 25% of the ocean floor has been mapped with high-resolution technology. The Mariana Trench, the most studied deep ocean feature on Earth, remains less understood than the surface of the Moon. What the cameras have brought back from its deepest zones has stopped being surprising only in the sense that researchers have learned to expect the unexpected. Even that expectation keeps getting exceeded. Mystery number 1, the barrelly fish and its transparent skull. The barrelly fish, Macropinna microstoma, had been known to marine biologists for 70 years before anyone understood what it actually looked like. Every specimen brought to the surface arrived destroyed. The pressure change during ascent collapsed the transparent, fluid-filled dome that sits over the fish's head, leaving researchers with a mangled sample and a persistent question about what the dome was and what it was doing there. For 7 decades, scientists worked from broken evidence, noting the unusual eye structure, filing it and moving on. In 2009, researchers at the Monterey Bay Aquarium Research Institute sent down a remotely operated vehicle fitted with low-light cameras and filmed a living barrelly at depth, dome intact. What they saw stopped the analysis room. The green barrel-shaped eyes inside the dome, the feature that gave the species its name, were not fixed forward as every prior researcher had assumed. They rotated fully. The fish could look straight up through its own transparent skull, while its body remained horizontal, tracking the silhouettes of prey moving above it against the faint residual light filtering down from the surface. Researchers proposed the rotating eyes evolved precisely for that purpose, hunting from below in near total darkness, using the last trace of light available at that depth as a targeting system. The dome itself remains only partially explained. Its fluid composition, its structural behavior under pressure, the precise optical role it plays beyond simple protection. None of that has been fully characterized in the 15 years since the footage was filmed. A fish with a transparent skull and rotating eyes spent 70 years being studied from broken specimens. The question that does not go away is how many other animals are sitting in specimen jars right now, fundamentally largely misunderstood because no camera has reached them alive. The next creature was reached alive, at a depth where complex life was not supposed to exist at all. Mystery number 2, the Dumbo octopus. The assumption had always been that below a certain depth, the energy cost of being an octopus becomes unsustainable. Cephalopods are complex animals. They move constantly, hunt actively, require continuous oxygen. The deep ocean offers almost none of what that biology demands. At some point, the math stops working. Grimpoteuthis did not get the memo. The Dumbo octopus, named for the ear, like fins that extend from either side of its mantle, had been observed by a remotely operated vehicle since the 1990s. But it was a 2020 deep-sea survey conducted by researchers from Mbari and the Schmidt Ocean Institute that pushed the confirmed depth record for the species to 7,000 meters, making it the deepest living octopus ever recorded by a margin that genuinely surprised the team that found it. At 7,000 meters, the pressure is approximately 700 times greater than at the ocean surface. It is a pressure that would destroy the cellular structure of a shallow water cephalopod within seconds. Grimpoteuthis was not destroyed. It was hunting, moving fluidly, pursuing prey, maneuvering with the same behavioral repertoire as an octopus in a coastal rock pool. Its fins worked, its body held. Researchers proposed that the species had developed pressure, adapted proteins, and a modified cellular structure that prevented the enzyme disruption responsible for killing shallow water animals at extreme depth, an adaptation likely accumulated across millions of years of gradual descent into deeper water. The specific genetic and biochemical mechanisms behind that adaptation have not been fully mapped. Scientists know the adaptation exists because the animal is alive and functional at 7,000 meters. They do not yet fully understand, at the molecular level, how. If a complex active predator solved the problem of surviving at that depth, the question that follows is how many other solutions to that same problem are sitting undiscovered in the zone below it. The next creature was not discovered by going deeper. It was discovered by finally believing the people who had been describing it for over a century. Mystery number 3, the giant isopod deep sea fishermen working the Gulf of Mexico had been pulling them up in trawl nets since the 1870s. Enormous armored crustaceans, some over 45 centimeters long, resembling pillbugs, scaled up to a size that had no business existing. They brought specimens to port. They described what they had seen. Scientists looked at the accounts, looked at the specimens, and largely set both aside. The giant isopod, Bathynomus giganteus, was formally described by French zoologist Alphonse Milne. Edwards in 1879 from a Gulf of Mexico specimen. That formal description did not translate into serious scientific attention. The species spent most of the following century in a peculiar limbo, officially named officially real, and almost entirely ignored by mainstream marine biology. When deep sea RAV surveys began reaching the species in its natural habitat in the 1990s and 2000s. What the cameras found exceeded even the fishermen's accounts. Specimens photographed in situ reached over 50 centimeters, and their behavior was the detail that stopped researchers cold. Giant isopods can survive without food for over 4 years, not by starving slowly, by shutting down. Metabolic processes reduced to a level so minimal that animals held in captivity were repeatedly assessed as deceased before showing signs of life again. The deep ocean offers almost nothing to eat, and Bathynomus giganteus evolved an answer to that problem so extreme it looks, from the outside, indistinguishable from actual death. Biologists proposed this metabolic flexibility developed in direct response to the feast and famine cycle of the deep sea floor, long periods of nothing, punctuated by the occasional fall of a whale carcass, large enough to sustain a population for months. The largest confirmed specimen on record measured 76 centimeters. Fishermen's accounts from the 1960s and 1970s describe animals larger than that. No survey has yet operated at sufficient scale across the species' full depth range to establish where the upper limit actually sits. Science dismissed this animal for a century, then confirmed it. They kept finding it larger than expected. The question of how large it actually gets has not been answered. The next creature was not dismissed. It simply appeared somewhere it had no business appearing and set a record that researchers are already racing to break. Mystery number 4. The snailfish at record depth in March 2023. A joint expedition by the University of Western Australia and Tokyo University of Marine Science and Technology lowered baited camera systems into the Izu Ogasawara Trench, south of Japan, a section of the broader trench system that receives significantly less research attention than the Challenger Deep. At 8,336 meters, the cameras picked up movement, a snailfish family Liparidae, moving actively across the sediment, alive, functional, and apparently unbothered by the pressure of 836 atmospheres bearing down on every centimeter of its body. It was the deepest fish ever recorded. By a significant margin, snailfish had already held that record before this expedition. A specimen filmed at 8,178 meters in the Mariana Trench in 2022 had pushed the previous record down by over 100 meters. The 2023 sighting pushed it 158 meters further still. What struck the researchers was not just the depth, it was the behavior. The animal showed no signs of operating at the edge of its limits. It moved the way a fish moves when it is comfortable, when it is home. The biology behind that comfort is what unsettles vertebrate researchers specifically. A snailfish's skeleton is not rigid. Its skull does not fully enclose its brain. Its bones, under the pressure that would shatter the skeletal structure of any surface fish, flex rather than fracture. This is not an accident of anatomy. It is a reversal of vertebrate lineage that evolved away from the skeletal rigidity that defines the trajectory of vertebrate evolution across hundreds of millions of years, trading hardness for survival at depth. Researchers propose this represents a secondary adaptation, evolution, running deliberately backward along one axis in response to a specific environmental pressure. That proposal has a consequence most people do not immediately register. If evolution can reverse that direction under sufficient pressure, the theoretical depth limit for vertebrate life is not fixed. It is not where anyone currently places it. The 2023 record was set in March. By the end of that year, multiple research teams were already designing expeditions to go deeper. Where the actual limit sits, nobody knows. What comes next is not a creature that broke a record. It is a phenomenon that broke a category. Mystery number 5. The Hadal amphipod swarms. They are not the most dramatic creature in the trench. They are not the largest, not the strangest looking, not the kind of animal that stops a camera crew mid-sentence. Hirundelle gigas, the Hadal amphipod, is a small crustacean, a few centimeters long, that lives in aggregations at the deepest points of the Challenger. They eat thousands of them, sometimes tens of thousands, gathering around any available food source at depths exceeding 10,000 meters. The swarms themselves were documented by baited camera systems deployed in the 1990s and 2000s. And the scale of the populations initially struck researchers as difficult to account for. The Hadal zone offers almost nothing to eat. A population that large at that depth, sustaining itself on whatever organic material happens to sink from the surface 11 kilometers above. The energy budget did not add up cleanly. In 2017, researchers from Newcastle University published the result of chemical analysis conducted on amphipod tissue collected from the Challenger Deep. What they found had nothing to do with the animal's biology. The tissue contained persistent organic pollutants, PCBs, flame retardants, industrial chemicals at concentrations 50 times higher than levels recorded in crustaceans living in heavily contaminated, heavily industrialized river systems on the surface at 10,000 meters. In the most remote, most isolated point on Earth, researchers proposed the most logical available explanation: contaminated organic matter sinking from the surface over decades, accumulating in the deepest zones where no current carries it away, entering the food chain through the amphipods feeding on it. The concentration levels did not support gradual surface fallout alone. The chemistry pointed toward a more direct pathway, something moving those pollutants into the deepest ocean faster and more efficiently than passive sinking could account for. That pathway has not been fully characterized. The most isolated point on the planet has industrial contamination exceeding polluted river systems. The mechanism that put it there is not completely understood. Something is connecting the surface world to the bottom of the ocean more directly than the models predicted. And if that connection runs in one direction downward, the question of what it carries with it, beyond industrial chemicals, is one that researchers have not yet fully asked. The final entry in this video was recorded, reviewed, analyzed by serious researchers with serious equipment, and then quietly set aside. Not disproven, set aside. Everything covered so far has an explanation attached to it. Incomplete, contested, still being revised, but an explanation. A biological mechanism proposed, a depth record contextualized, a contamination pathway partially mapped. The final entry has none of that. What it has is a recording, a frequency profile, and a 40-year. The old question that the scientific community answered once and then stops asking. In 1997, hydrophone arrays operated by the National Oceanic and Atmospheric Administration detected an ultra-low frequency underwater sound in the South Pacific. The arrays that picked it up were nearly 5,000 kilometers apart. For a sound to register simultaneously on sensors separated by that distance, the source had to be extraordinarily powerful, orders of magnitude beyond anything a known marine animal produces. NOAA researchers named it the bloop. The frequency profile was the detail that stops the analysis team. They imaged the profile of a biological source, not geological, not volcanic, biological, the kind of signature produced by something alive, contracting, moving. No known animal on Earth generates sound at that volume. Not blue whale, the loudest biological sound producers documented, not any cetacean species, not anything in the marine acoustic record. In 2012, NOAA released a revised explanation. Icequake activity. The fracturing and movement of Antarctic ice sheets can produce ultra-low frequency sounds across enormous distances. The bloop the agency proposed was most likely a large-scale icequake event. The story was largely considered resolved. Most publications moved on. What did not move on was the acoustic signature itself. Researchers at the Woods Hole Oceanographic Institution, reviewing the frequency data independently, noted in analyses that were not widely circulated that the bloop's specific acoustic profile differed from documented icequake signatures in ways that the icequake explanation did not fully account for. That finding did not make headlines. It sat in technical literature. The icequake theory explains the frequency range. It does not explain the profile. Both of those things remain true simultaneously, and no single explanation has been formally adopted by the full research community in the 27 years since the recording was made. The Mariana Trench contains vertebrates at 8,336 meters, complex active predators at 7,000 contamination pathways that move material from the surface to the bottom faster than current models predicted. And somewhere in the South Pacific in 1997, something produced a sound at a volume no known animal can produce, with a frequency signature that matched a biological source. What was in that water in 1997 is a question that has not been answered. It has only been set aside. Every creature in this video solved a problem that science had declared unsolvable: pressure that should crush, darkness that should starve, cold that should stop every metabolic process worth running. Each solution took millions of years to develop. Each one went undiscovered until a camera finally reached reach the right depth at the right moment. The Mariana Trench is not the bottom of the ocean. It is the bottom of what we have managed to look at so far. Less than 25% of the ocean floor has been mapped. The deepest fish record has been broken twice in 2 years. The loudest unidentified sound in the marine acoustic record remains unexplained. The distinction between what we know and what is actually down there is not closing, it is expanding. Of the 6 creatures in this video, which one do you think has the most left to teach us? Cryptic finds will keep going deeper until we find out.